Inertial frames of reference. An inertial frame of reference is one that is not undergoing acceleration. For any inertial frame of reference, the laws of physics are the same, regardless of the velocity of the frame of reference in terms of any other frame of reference. A laboratory in a school is generally considered to be an inertial frame of reference, as the building and all objects in it have the same velocity due to the rotation of the Earth. However, in the vertical direction, the building and its contents are subject to acceleration due to gravity, and this can be easily detected. An experiment as simple as dropping a ball will reveal that in the vertical direction, the frame of reference is being accelerated. However, the acceleration due to gravity will be the same for any frame of reference on the surface of the Earth. In terms of the surface of the Earth, a science laboratory is an inertial frame of reference. Likewise, a train carriage moving with constant velocity along a perfectly straight and level track is considered to be an inertial frame of reference in terms of the surface of the Earth. A spacecraft orbiting the Earth is also generally considered to be an inertial frame of reference. The astronauts and their vessel are all in free fall towards the Earth. Both the occupants and the vessel have nearly the same weight and exactly the same mass as they do on the surface of the Earth. But relative to the frame of reference of the spaceship, the astronauts appear weightless. The acceleration due to gravity of the astronauts relative to the spaceship is zero. A truly inertial frame of reference would be a spaceship moving through deep space at a constant velocity well away from any stars or planets. Supposing that we had such a ship, and on board the ship there was a scientist. The scientist conducts an experiment in which he releases a ball carefully so as not to impart any force to the ball when he releases it. In the frame of reference of the scientist, the ball will remain stationary in the position in which it was released. Non-inertial frames of reference. A non-inertial frame of reference is one which is accelerating, either in terms of a change of velocity or a change of direction. An accelerating vehicle is an example of a non-inertial frame of reference. A weight suspended by a piece of string from the roof of an accelerating vehicle will hang at an angle, appearing to be subject to a force in the opposite direction to the acceleration of the frame of reference of the vehicle. You can see in the diagram that the pendulum hanging from the roof of the train carriage is hanging at an angle theta as the train carriage is being accelerated. The angle theta equals tan to the minus 1 a over g, where theta is the angle to the vertical and a is the acceleration of the vehicle. G is, of course, acceleration due to gravity. Suppose we were to cut the string suspending the mass from the roof of the train carriage. What would happen? Let us assume that the train is accelerating in the forwards direction at a steady rate along a straight, perfectly even and level track. To an observer in the train carriage, the ball would appear to move in a straight line in the direction of the string before it was cut. That is, at an angle theta equals tan to the minus 1 a over g, where a is acceleration and g is acceleration due to gravity, to the vertical. To an observer standing beside the rail line, the ball would appear to follow a parabolic trajectory, defined by its lateral velocity when the string was cut and acceleration due to gravity. Both observers would be correct within their respective frames of reference. An accelerating spaceship is a non-inertial frame of reference, and if it is accelerating at 1g, the occupants would experience the same force as provided by gravity on the surface of the Earth. In terms of an object dropped within the frame of reference, to an observer in the frame of reference, the effects would be indistinguishable. To a stationary observer outside the frame of reference, the two situations would appear very different. Two moving observers. Imagine that there are two spaceships travelling through deep space, well away from any stars or planets, that pass close to each other. Both spaceships are moving at a constant velocity of 1,000 kilometers an hour, but in opposite relative directions. Each spaceship has an observer with a science laboratory. An observer in either ship could not tell from within their spaceship that he or she were moving. From their perspective, the other spaceship would pass them at 2,000 kilometers an hour and they would be at rest. If one of the spaceships was traveling backwards at 1,000 kilometers an hour and the other spaceship forwards at 3,000 kilometers an hour, from the perspective of an observer in either ship, the situation would be the same. The principle of relativity. For any inertial frame of reference, the laws of physics are the same, regardless of the velocity of that frame of reference in terms of any other frame of reference. Provided that the frame of reference of an observer is not accelerating, the laws of physics will be followed as if the frame of reference was stationary. The velocity of an inertial frame of reference cannot be determined by any observation or experiment within the frame of reference. To say that something is moving is almost meaningless. You can only say that something is moving relative to something else. A simple practical activity that you can carry out in order to determine if a frame of reference is inertial. All you need is a weight and a piece of string or cotton. Use the weight and a piece of string to construct a plumb bob. When the vehicle is travelling in a straight line at constant speed, the plumb bob will hang vertically. If the vehicle accelerates, either in the direction of travel or laterally as a result of cornering, the plumb bob will no longer hang vertically. It will behave as if it is being accelerated in the opposite direction to the acceleration of the frame of reference. A similar experiment can also be carried out with a helium balloon. The procedure is, once again, very simple. Attach a helium-filled balloon to a fixed point in a vehicle by its string, or alternatively, hold the balloon by the string in such a way that the balloon is free to float and to move both side to side and fore and aft. Observe what happens to the balloon when the vehicle is moving at constant speed, accelerating, decelerating, and cornering. You will find that the balloon will tend to orient itself in terms of the equivalent field direction or the apparent strength of gravity, which will be made up of the acceleration due to gravity and the acceleration due to the movement of the vehicle. Summary. An inertial frame of reference is one that is not undergoing acceleration. A science laboratory in a school is generally considered to be an inertial frame of reference, as is a train carriage moving along a perfectly straight and level track with uniform velocity. A spaceship in orbit about the Earth is also generally considered to be an inertial frame of reference. For some rigorous thought experiments, people are asked to imagine a spaceship travelling through deep space well away from any stars or planets with constant velocity, as this is a truly inertial frame of reference. For any inertial frame of reference, the laws of physics are the same, regardless of the velocity of that frame of reference in terms of any other frame of reference. Provided that the frame of reference of an observer is not accelerating, the laws of physics will be followed as if the frame of reference was stationary. The velocity of an inertial frame of reference cannot be determined by any observation or experiment within the frame of reference. The acceleration of a non-inertial frame of reference can be detected from within the frame of reference using a device as simple as a plumb bob or a helium-filled balloon. An event in one frame of reference can look very different to an observer within the frame of reference compared to how the event is seen by an observer outside the frame of reference.